What happens when your main router fails? Your entire network goes down unless you've configured HSRP. In this video, I'll show you exactly how to set up a bulletproof virtual gateway that automatically fails over to a backup router with zero downtime. Want to see a real lab demo where we crash a router and watch the magic happen? Stick around! In this practice lab, we will create an HSRP IP on the two pastes of the router that leads to the networks of PC1 and PC2. Currently, the PC1 can join loopback at the other end. If from PC1 we ping the IP of loopback 0, it works fine. Now, we are going to cut the link between router 1 and switch 1 by doing a shutdown on the Ethernet interface 00 of router 1. If you restart a ping from PC1 to loopback 0, this time it doesn't work anymore. There is therefore no redundancy in implementation, as the default gateway of PC1 is the 0pin0 Ethernet interface of router 1. The only solution to make the PC1 work again would be to manually modify its gateway by the IP of the router interface that still works. That is, the IP of the 0 and 0 Ethernet paste of router 2. 10.10.1.3. That's why we're going to use the HSRP protocol, so that the flows can pass to the other side automatically, in case of failure of one of the two routers. Now that we've seen why we should use HSRP, we're going to reassemble the 00 Ethernet interface of router 1 by making it a no shutdown. If we run a show IP interface brief on this same router, we see that the IP of the interface 00, the one on the PC1 side, is 10.10.1.2. And if we run the same command on router 2, we can see that the IP that points to the PCs is 10.10.1.3. So we're going to choose IP 10.10.1.1 for HSRP as it's not used. To configure the HSRP, we will start by connecting to the Ethernet 0 paste of router 1 and making it a standby 1 IP 10.10.1.1. We will wait for a log message to appear on the console to confirm that router 1 has an active HSRP. Once activated, the latter will listen to the hello messages from HSRP to see if there is another router configured with the same HSRP group. So at this moment, he is of course all alone. It will therefore automatically become the HSRP active. If we look plus in detail at the console's logs, we can decipher that it started listening before becoming the asset. The show standby command is used to monitor the status of the HSRP on the routers. The output of this command shows us that router 1 is the primary one and that the secondary router is not known because we have not yet configured router 2. Standby router is unknown. We can also see that a virtual MAC address has been associated with the virtual IP 10.10.1.11. So we now do a show interfaces Ethernet $0. We can see that the virtual MAC address is different from the one associated with port 00. We will immediately analyze this MAC address story. If you ping PC1 to the HSRP address 10.10.1.1, it works perfectly, and even if we ping to the loopback address at the other end, it works too. We will now display the ARP table of PC1 with the command ARP-A. Here, we can clearly see the virtual IP that is associated with the virtual MAC address, and not the MAC address of the 00 interface of router 1. Now, let's move on to setting up the HSRP on router 2. We connect to the Ethernet SIL port, and as for router 1, we make it a standby 1 IP 10.10.1.1. We will wait a few seconds to receive the logs on the console. As router 1 is already active, router 2 receives hello packets from it and automatically goes into standby. On the other hand, if it no longer receives hello packets from router 1, it seems to me that it's after 3 hellos lost. Then it will automatically switch to active. Here, the log confirms that router 2 is on standby. If we do a standby show on router 2, we see that even though it is on standby, it uses the same MAC virtual address for the HSRP IP. We also see that the active router carries the IP 10.10.1.2 if we run the show standby on router 1. We can see that the standby router carries the IP 10.10.1.3. It's the one for router 2. Now, since we have just configured HSRP 10.10.1.1, which includes point 2 and point 3, we can change the gateway of the PCs. In the IP configuration of PC 1 and 2, we will put the virtual IP of the HSRP as the default gateway. That is to say, 10.10.1.1, modification of PC1 gateway to point row 1. PC2 gateway, modification to point 1. In this way, there will no longer be any need to intervene on the PCs in case of failure of one of the routers. To check, we will cut the link between router 1 and switch 1 again with the shutdown command on port 00 of router 1. We can see in the logs that the HSRP has gone from the active state to init. If we quickly do a standby show, we see that it knows neither the active router nor the standby because it can no longer communicate with its link, which is down. On the other hand, if we open the CLI console of router 2, we can see that there is a log that indicates a change in state for the HSRP. Router 2 is now the active router. This can be verified with a show standby. Here, we also see that the standby router is not known because the link is cut. The IP address and the MAC address do not change. With an HS router, if from PC1 you restart a ping to the loopback on the other end, it should work without any problem. The packets will flow through switch 2 and router 2 to join loopback 0. With an ARP-A on PC1, we see that the IP address and the MAC address don't change either. To finish the TP, we will reassemble the 00 interface of router 1 with the no shutdown command. We'll wait for the log to appear, and now we can see that it has gone on standby. It will not return active because it has not been prioritized. If we do a standby show, we can see that the preemption is deactivated. In HSRP, it is possible to set priorities for a router to become active again once it is accessible again. This is the end of our lab on the redundancy of the default gateways. Don't hesitate to do and redo the lab on your own using the controls that are available. The ideal is to type the commands by hand and not to copy and paste. This is the best way to memorize them. I say, see you soon in the rest of the training.